Hello and welcome to our next video where we will create a MITRE object within Python. Now, what exactly does that mean? If you go into the MITRE GitHub and look at their CTI repository, there are different attack versions, okay? And if we go into enterprise attack, and if we look, they have an enterprise-attack JSON file here. In this JSON file, there is an absurd amount of data in here. It sometimes breaks my browser just trying to comb through this via a browser. Control F also sometimes breaks it. So be careful using it from this perspective, but just know that it is essentially a JSON file of all of MITRE attack. So if you think about the matrix for MITRE, every single piece of data in here is essentially represented in that JSON file. So if I wanted to look up the resource development tactic, the compromise accounts technique, and the email account sub-technique, that is represented in this JSON file here. We're going to dig more into that in a bit here. Okay, so now that we know the object of the game here, what we want is to grab this file and essentially parse through it and to make the data easily accessible for our next iteration of our validation script. Okay. So what we're going to do, make another Python script. Just call it MITRE.py. And first off, we're going to import requests. That is the module by which Python can send web requests and gather data. I don't quite remember if this is installed by default or not, but if it's not, you could type in pip3 install requests on your command line, and that should download the appropriate module for you. Okay, so first off, what are the different pieces of a request? You're going to have a URL. You're going to have some headers from your web request, and then you're going to have some kind of function. All right. Using this core template here, you can make requests in a lot of different ways. What we're going to do is navigate to this raw github-user-content.com link. You can get that just by clicking enterprise attack and then viewing raw. This will spin for a while, so I'm just going to close out of it, but it'll pop you up to this page. Okay. So we're going to grab that URL, put that in here. And then for our headers, if you notice, this is a JSON file, so we have to put in accept application JSON. There we go. I can't type apparently. All right, so we have our headers in here. And now looking at our requests, how they work, you type in the URL first. You have to declare the headers. So the headers equal headers, which is just what we put here. And then what we could do is make sure that data is coming in via JSON. We could put all that data in the request in a variable. And then we can look at that data by just printing out the object that we're creating. So let's run this and see what happens. As I said before, this JSON file is ridiculously large, and you can see it finally finished, but it's essentially printing out all the data that we saw here, just accessible within this object within Python. If this is all we needed, that'd be great. It'd be easy to work with, and we can kind of call it a day. But what I like to do is kind of filter through this and create a smaller object that we can use throughout our different scripts. Okay. So to do that, we're going to make a function that iterates over this data and creates a smaller subset of it. All right. So we're going to get a mapping of MITRE data, which is the function. And what I think is helpful here is to try to find one specific technique that we want to look at within here. So if we look at, let's say, one of our custom alerts that we have here, let's look at this Posh audio capture one here. All right, so we have this audio capture technique, that's T1123. And just using this audio capture as an example, if we go into our raw.github user content and Control F a bunch of times, what you'll see is the URL here for T1123. If you scroll up a little bit, you can see the name audio capture, which does line up here. Okay. And if you look, you can see this is where the object starts and this is where it ends. So we can do, let's grab this chunk of text, throw it in something called Scratchpad maybe. And we can see all the pieces of information that we want to pull out of here. So when thinking about how do we peel apart this giant mass of data, we really only care about the techniques and the tactics that they sit under, and all the data that we want is in here. Okay, so looking at from top to bottom, we like the name, we like the phase name, which is the tactic, we like the URL, and we like the TID. So the whole end goal with this MITRE script and this mapping that we're going to try to make is to consolidate all this data down into those fields that we care about. Okay, so going back to our script, let's leave this Scratchpad here. I'm going to save it. Let's go back to the very top of this document. So if you look at the start here, we have some IDs here. We have something called objects, which seems to kick off everything. We'd probably have to scroll down to the very bottom of the document. And then if you see spec version, okay. So from here, I don't really know how many lines of code that is, but moving up to the top, we really only have 4 pieces of information. We can confirm that. Before we dive to the whole function here, let's iterate over the data and then see what happens. So for X, MITRE data, print X. And this should be very similar to our other script where we're iterating over the TOML. Now we're iterating over a extraordinarily large JSON file, okay? So if we run this, oh, I didn't like the size of my screen there. Let me run this one more time. See type, ID, objects, and spec version. And that kind of confirms what we were supposing based off of just eyeballing the data, okay? So what we care about are objects, all right? And what we're going to do as an exercise is to find these pieces of data within here. So we're going to say for object in MITRE data. And since we already know objects, we don't have to iterate over type, ID, spec version. Say objects. We can now print out the object and then see what data comes back. And again, there's going to be a lot here. Okay, now looking at the bottom here, we can see these types are relationship, which is a piece of MITRE, and they relate different pieces of data together through that relationship lookup. So if you think threat actors to techniques or techniques to mitigations, those are all defined in this data as well. But what we care about in the Scratchpad is this type attack pattern, okay? So what we want to do is say if object type equals attack pattern. And we're going to print, let's print the name. We can see all the names of everything that's considered attack pattern within MITRE. So now that we know that these objects are printing properly, what we want to do is ensure that the fields that we need exist. I'm kind of giving you the answer here really quick because that data set is so large and it's kind of hard to parse through the first time if you're not already aware of this. But some of these fields, for example, external references could be blank, or we could have an attack pattern that might not have an external ID, and those aren't the ones that we care about. So what we want to do is to ensure that the external underscore references exist in the object. And to do that, we're going to say if external underscore references in object. So we're essentially just confirming that this field exists within the object that we're looking at. And then if we look into this reference here, we have a subset of references, right? So what we want to do is to print out this data. So we can say something like, for reference, in object external references. And we're going to print the reference just to see what comes up here. And what we should see when it returns back is a bunch of TIDs. So we can see items like this, and this is what we care about. Okay, but it's printing everything out here. And if we want to hone in on just items that have an external ID, which is what we want to do, we could add another check. So now, similar to this process here, we're now ensuring that external ID is contained within reference. And now we see something more manageable here where we have all the TIDs, we have all the URLs. So now that we have enough checks, we can then manipulate the data and then store it somewhere. So we're going to create a couple of variables here. We can say, let's say technique is the external ID. Okay, so the technique variable will be the TID. The name of the TID is already in the data, and we're just going to call it name. So going back to this example, instead of digging into here, we're doing the checks to make sure that TID is here, but then we're going to grab this name up here. And now we're going to grab the URL. So what we can do to just verify this really quick. And this is a helpful technique you can use when you're just verifying some data before you do something more complicated with it. All right, and now we can see some TIDs. We can see the name and then the URLs associated with them. The caveat with how we're doing things here, and you'll notice we have a CAPEC-561 right here. Okay, and we don't want those in our data, right? So that's not MITRE attack. That is capec.mitre. Okay, so what we want to do is have another check to ensure that the TID starts with a T. Okay, we're actually going to do it right below this check here. Okay, just looking at this really quick, we're saying if this first column essentially starts with a T, we can now declare the variables and print them out. So if we run this again, this CAPEC ID right here should go away. And there we go. Now we have a nice consolidated list here So all that's left is to ensure that we have the tactic in here and to make sure we have a check to see if the alert is deprecated or not. If we look back to our reference scratchpad here, the tactic is under kill chain phases and then phase name. So what we can do is just add another check similar to how we've done it a couple times before. Before we start declaring some variable names, we just want to test this. Okay. So we're saying if kill chain phases exists in object. Let's print this out. And just pointing out as we develop this, we're taking a very iterative approach. We're taking each step piece by piece and making sure they work before continuing on to the next step. Okay. So just look through this now that it returned back. We can see MITRE attack as kill chain phase names. If we kind of scroll through all of these, that's pretty consistent. So we're not going to have to filter on that. And then we can see phase names, and these are the tactics we care about. If you'll notice, some of these have 2 values, which is interesting. And this is a great example of why you want to print some of your data before you start utilizing it, because if we didn't take into account multiple values, we would have coded this wrong, and it probably would have taken a lot of time once you realized that something wasn't working right in production, and then you have to trace it back all the way to the script and where it went wrong. Okay, so now that we know that there's multiple values, what we can do is loop over those. Okay. So let's say something like this. And now we have all these broken out. And what we're going to want to do is to store this data in an array so we can utilize them later. Okay, so what we're going to do for each object, we're going to declare this tactics array, and this is going to reset the array every time there's a new object, which we need. Okay. So what we're going to do is say tactics.append tactic. All right. And now let's do something like this. And if you'll notice, it doesn't like us using lists as a string. So what we can do, convert that. All right, now we get some data back. So you can see here, it's returning back TID and the whole tactic phrase for each one. So an example where we have multiple values, like this TID here, in which there's multiple different tactics, it's chucking in the whole array that's found in here. So we want to tighten that up a bit. We only really care about these phase names, so we can be a little bit more explicit and do something like this. And now we have a nice listing of the tactics that are associated with the TID. Okay. So we solved one of the 2 tasks that we want to accomplish before making our object. Okay. So next up is checking if data is deprecated or not. And this is a little tricky because if there isn't any deprecation, the field that we're looking for doesn't exist in the data. And using the scratchpad as an example, we don't see any field of deprecation. But if we go into the MITRE data, and let's say we type in x_MITRE_deprecated, you can see that this key value pair here is inserted into techniques that are deprecated. Okay. So we want to make sure we check that. Ultimately, this data is to be used for our validation script, and we want to eventually write a check to make sure that the technique we're using is not a deprecated alert. Okay. So going back to our script, Let's add that in. So we're going to do one more check here. So we're saying if that field exists in a given object, so we're creating a field called deprecated. And then what we can do just to test this out, the Boolean value. So we're going to convert that to string. And there we go. We now have a big dump of all the alerts within MITRE. And just to double check this, what we can do is, let's say, take this system shutdown / reboot, and let's go into our data and see what we can find. Okay, we can see system shutdown / reboot, and we can see that the X MITRE deprecated is right here, and it is false. And then what we can do is, let's say, take one that's true. Let's say multi-band communication here. We can see the attack pattern. And then X MITRE deprecated is true. Okay, and just if you're curious, what you can do is grab the URL for that. And then you can see on their main webpage here, multi-band communication, deprecated, no longer used. Sometimes when alert gets deprecated, it gets replaced with a different technique name or type of technique. And sometimes they'll put a link in here that you can use. But this field is just showing if a technique is deprecated or not. All right, and going back to this as an example, we can't rely on that field to always say true or false because not all techniques are kept up with that name value pair. Okay, so what we're going to do is account for that. So we're going to say if MITRE technique and object deprecated is going to be a true or false value. And what we're going to do next is essentially create a filter and take all the variables that we declared above and then chuck it all to the filter and save that filtered list to an object. We can start by setting it up here, and then we can go and add all these in. Okay, so let's put in tactics. And then we could do technique. URL. And deprecated. All right, just to make sure this works, what we should be able to do is print out this filtered object. And a good example here, we can see the tactics all being listed out. See the techniques, the name, the URL, and if the technique is deprecated or not. Okay. But now we have to figure out what do we do with the object chunks that don't have that X MITRE deprecated. Okay. So what we're going to do with something very similar. We're going to create another filtered object variable. And then instead of putting deprecated as the variable, we're just going to put in false. What I've discovered through my own poking around when I initially went through this process of creating these scripts is that if there isn't a deprecated equals true, then 99 out of 100 times that I've seen, the technique was not deprecated. Okay. And now what we want to do, since we have our single line variables here, we need to store it somewhere else. So then we can use that container of data in the rest of our scripts. So we could call this something like MITRE mapped, maybe. And technique is the filtered object. We haven't declared this yet, so what we're going to have to do all right, so now we're initiating it up here. And then putting all the data in down here. So what does this look like? We now have a complete listing of all the data, and we're using the TID as the key. All right. So what that means is, let's say we're using this as an example. Let's say we want to grab the name of this TID. What we can do, if I can copy and paste correctly, is look up the data via the TID and then print out one of the field names. Okay, now we have audio capture. All right, what if we want the URL? We get the URL. All right, now here's the kicker. What if we want the deprecated value? False. Okay. And just double checking this as a sanity check. We can do, let's grab the URL, go to our Firefox, and it's not a deprecated alert. So that all checks out. And we now have a usable MITRE object that we can use in our scripts. And earlier in this video, we were going to set this up as a function. If you want to run this multiple times or do different things with it based off of the function, you can do this as well. But for now, I'm just going to leave it as is and close out this video. Hopefully this has been helpful in showing how we can take a very large data set, and with a little bit of work, a little bit of digging and filtering down, we can create something smaller and easier to work with. In the next video, we'll figure out how to use this data to make checks in our validation.py script. Thanks for sticking with me. I'll see you in the next one.